Welcome to the lesson on Java Methods Part 2. We will talk about a special method called the constructor. We will also talk about method overloading as well as passing arguments to methods. Let's start with the constructor method. When a constructor is invoked, it builds and returns an instance of the class. Constructors do not have an explicit return type. There is a special type of constructor called a default constructor that does not take any parameters. You do not need to explicitly include the default constructor unless you include other constructors that have one or more parameters in them, or if you simply wanted to initialize some class properties. Let's take a look at a sample class called box. This class has three properties: height, width, and length, all declared as int types. It also has a default constructor, as shown here, which has no parameters passed into it and simply assigns the value 0 to each of the class properties. There's another constructor defined here, line 26, that passes in three parameters h, w, and l of type int and assigns them over to the class properties. There's another method called getVolume in box. Let's take a look at how this box is used in terms of calling its constructors. So let's declare a variable called b1 type box and instantiate it as a box. Let's go ahead and display the value of the height variable of b1. And let's also call the getVolume method of b1 as well. Let's also call the other constructor and assign it to the variable called b2, passing in the values 10, 20, and 30. To display its height, to display its volume as well. Notice the first line of output is 0, which comes from the default constructor's assignment here. The second line of output is 0, which comes from the getVolume method multiplying all the properties together. The next line of output is 10, which comes from this value here. And the last line of output is 6,000, which is the multiplication of 10 by 20 by 30. This leads us into the concept of method overloading. Method overloading is when two or more methods have the same name but have different parameters. The advantage of method overloading is less overall complexity because there's less names to keep track of for methods that basically do the same thing. Let's take a look at a class that demonstrates this concept called overloaded methods. It has two methods, both of the same name, called max. The first method returns type int and passes in two integer values n1 and n2. The body of this method compares both of those values to see which one is greater and returns the greater value. The second max method returns a string type and passes in two string types, s1 and s2, and does the same thing as the max method above by using strings, by using the compare2 method. Let's go ahead and take a look at how these methods are used. Let's declare a variable called om of type overloaded methods and instantiate it as an overloaded methods type. Let's declare a variable called max1 of type int and call the first max method on om, and let's display that value as output. Let's declare another variable called max2 of type string and call the second max method, passing in two string literals, test and tell. And let's display the value of max2. So as you can see, the first line of input is 233, which obviously is greater than 199. The second line of output is test, which is greater alphabetically than the value tell. Let's now shift gears a little bit by looking at parameter passing for methods. For primitive types, Java passes by value, meaning that a copy is sent and the original does not change. When an object is passed, on the other hand, to a method, it uses pass by reference, meaning that it will refer or point to the same object as referenced by the object. Let's take a look at two classes, employer and employee, to demonstrate this concept. Employee has two properties, name and pay rate, name of type string and pay rate of type double. It also has a compute my salary method. Employer has a single method called promote, which passes in an employee type. The body of this method increases the pay rate by 0.25. Let's take a look at how pass by reference is used by using these classes. So let's declare an employer variable reference type of employee of employer and instantiate it as an employer. Let's do the same and set up an employee of employee type and instantiate it as an employee. Let's go ahead and assign values to the name variable of employee and the pay rate of employee. Let's also set up a variable called sal, short for salary, as type double, and invoke the compute my salary method on employee. And let's display that as output. Let's now call the promote method on employer, passing in the object employee, and then call the compute salary again and display that value as output. The first line of output is 116,500, and notice how the salary changed, and the second line of output as 129,000. How do we get these values? Well, we started off with the pay rate of 1.33 at line 12. We then called the compute my salary method on employee and arrived at that first value, 116,500. We then called the promote method on employer, and if you recall, that increased the pay rate by 0.25. And after calling the compute my salary method on employee, we arrived at the 129,000 value. So the key here is this line of code here at line 15, where the promote method is called, passing in a reference type called employee. Employee's pay rate started off at 1.33 at line 12. It then got changed by the promote method, increasing it by 0.25, thereby changing the overall salary after you call the compute my salary method. Let's now take a look at a special case of pass by reference within the string class. You have to be very careful using the string types. Although they are reference type, they are immutable when it comes to parameter passing. Let's take a look at some classes that demonstrate this concept. We have a class here called string argument that has two methods called test. With overloading, the first method passes in a string type, assigns a string literal change to str. The second method passes in a type called more, which assigns the 22 value over to x, the x variable of more, and assigns the string literal howdy over to str of more. And let's quickly take a look at the more class, which only has two properties, x and str of type int and string respectively. Let's go ahead and demonstrate this concept of passing a string type into a method. So let's set up a variable called SA of type string argument and instantiate it as a string argument. Let's also set up another variable called s of type string and assign a string literal called test to it. Let's now pass s over to test of sa and then display s as output. Notice how we see the value test. As it started here, it got passed into the test method of string argument. There was an assignment of the string literal change to str, but the change didn't propagate through, thereby just leaving the ultimate value of s as still as test. However, on the other hand, if you pass another object type that contains a string instance variable and reassign it, that string value will actually change. So let's go ahead and demonstrate that concept by setting up a variable called m of type more, instantiated as a more. Let's go ahead and assign the x variable of m the value of 5. And let's assign the str variable of m the string literal hello. Let's invoke the test method of sa passing in m, and let's display the str variable of type m. So as you notice, we see the value howdy. At first, based on the above code, you would think that it would maintain the value hello. And notice how the string literal howdy is assigned over to str here in test. This concludes our video on Java Methods Part 2.